In the heavy-duty transport business, your profit margin is directly tied to how much weight you can move through brutal environments. That brings us to the Ashok Leyland 5532, the Taurus 3532AN, a 12-wheeler tipper that demands a rigorous financial evaluation before you add it to your fleet. This bar chart compares the standard payload capacity of a conventional 10-wheeler against the 5532. The sheer volume difference creates a massive profit gap on every single cycle. But acquiring that extra capacity comes with a strict financial trade-off. You are taking on a much higher upfront capital cost and a significantly heavier monthly EMI. And here is the operational reality. A truck built to carry massive loads generates zero revenue while it sits on cinder blocks waiting for a mechanic. So evaluating the 5532 means looking past its gross vehicle weight. The real calculation is about the specific engineering choices made to keep it out of the garage. Mining and heavy construction sites are unforgiving. The continuous exposure to extreme loads, dust, and jarring impacts guarantees heavy mechanical strain. These operations are entirely unpaved, deeply rutted, and often located miles away from the nearest paved highway. The math on these sites is grim. A single day of unexpected downtime can completely wipe out the extra payload profits you spent a whole week earning. The only way to justify the high initial cost of the 5532 is if its underlying architecture directly prevents these extended delays. Ashok Leyland tackles downtime through a specific strategy: modular design architecture. Historically, commercial trucks have been built with highly customized application-specific parts. When one of those unique components breaks, you wait days for the dealership to source the exact replacement. The 5532 shifts to a standardized system. The core components are shared across multiple vehicle combinations in the manufacturer's lineup. For the dealership, this drastically reduces the sheer number of unique parts they have to keep in stock to service a fleet. For the operator, mechanics can immediately swap out standardized modules rather than waiting on custom orders from the factory. This split-screen flowchart compares repair timelines. Top, the traditional model stalls as a custom part is ordered. Bottom, the modular approach instantly identifies and plugs in a standardized part, skipping acquisition delays. The result? Returning a disabled vehicle to the road under 6 hours. A multi-day mechanical failure is compressed into a half-day inconvenience. You miss a shift, not a week. The second major pillar of their uptime strategy relies on a completely homegrown engine technology stack. While competitors proudly market their foreign engine tie-ups, Ashok Leyland engineers and builds its engines 100% in-house in India. This requires fleet owners to accept a psychological trade-off. You let go of the prestige of a global brand badge in exchange for hyper-localization. A fully indigenous engine means every nut, bolt, and filter is manufactured locally. You are entirely insulated from international supply chain bottlenecks and imported part delays. It also means the engine mapping is tuned for the unique abuse of Indian roads, chronic overloading habits, and local fuel quality. The indigenous engine is a calculated supply chain advantage, designed to keep long-term maintenance costs at absolute rock bottom. Standardized parts and local engines are entirely useless if there are no mechanics physically nearby to install them. To back up their repair claims, Ashok Leyland has doubled their infrastructure in the last 2 years, expanding to over 1,000 outlets and 6,000 service personnel. They've strategically expanded out of their traditional southern stronghold, pushing deep into extreme, previously underserved territories in the north and northeast. Today, they maintain active service networks in some of the most punishing topographies on the continent, all the way up to Ladakh. For tipper operators specifically, they've deployed a tailored service model. Instead of towing a heavy rig out of a quarry, mechanics are dispatched to provide doorstep service right at the mining site. Combining fully modular parts, fully localized engines, and site-level mechanics creates a closed-loop system engineered to guarantee that 6-hour return-to-road promise. So, is the 5532 the right investment for every transport business? Absolutely not. If you deploy this truck in the wrong sector, it will become a massive drain on your profitability. If your routes look like this, smooth, standard highway logistics, this is the wrong tool for the job. For flat, standard freight routes, the heavy chassis and reinforced suspension of a 12-wheeler tipper drag down your unladen fuel economy far too much to make sense. Buying the 5532 for standard e-commerce or lightweight logistics is a complete waste of capital. The ideal buyer for this vehicle is a high-turnover business moving heavy aggregates, construction materials, or raw ore. You need an operating environment where extreme lifting capacity and rugged durability translate directly into cash. In these environments, the heavy-duty cabin absorbs the impact, reducing driver fatigue and allowing your crews to safely complete more cycles per shift. The return on investment formula here is strict. Massive payload plus modular uptime equals accelerated project completion. This quadrant chart maps the financial reality. While standard heavy trucks often fall into high downtime and moderate profit, the 5532 is engineered to sit firmly in the low downtime, high profit quadrant. The higher upfront EMI is quickly neutralized by the sheer volume of uninterrupted heavy trips the truck completes over the course of a month. For the dedicated mining or construction contractor, the AL5532 is a specialized tool designed to out-earn the competition through relentless uptime.
रोजाना मैकेनिकल ज्ञान के लिए सब्सक्राइब करो। फ्यूचर में कैरियर बनाना है, डेली लर्निंग करो।